Hello, Karthik and Bob. Thanks so much for taking the time to chat with me today. There's been a lot of attention lately on how kind of companies report their emissions and accuracy thereof. But the reality is that most of today's carbon accounting approaches still rely heavily on estimates or regional averages, which might work for high-level disclosures, but it doesn't really hold up when we need credible, auditable data, especially at the product level, which is kind of where real decisions get made. We know that the E-liability model flips this model, starts from the bottom up rather than the top down, with each company measuring its own direct emissions and passing that along the value chain, just like in inventory accounting. And once this approach sort of becomes universal, those direct emissions are really the only emissions that are being measured. So this is why direct measurement and assurance are so critical to discuss. You need accurate data at the source, and independent verification measurement or mechanism to trust it. So today I would love for you guys to kind of walk us through what the different approaches to direct measurement are, and how the E-liability approach verifies these direct emissions calculations all throughout the supply chain.
Excellent. Well, thank you for that introduction, Sandy. And I think maybe a useful place for us to start is the demand for this. And the reason for direct measurement of emissions is that it allows companies then to be able to competitively differentiate their products based on their embedded emissions. Politicians in a number of countries have identified that their industries have made investments in things like clean manufacturing or clean energy and clean sourcing. And the drawback to those investments today is that there's no way for companies to monetize that. So imagine if you're a manufacturer and you've invested in making all these clean innovation, clean manufacturing improvements, and then there's no way to actually communicate that to your customers so that your customers are able to prefer or purchase your product over your competitors' products, maybe even pay you a premium for it. So that's the reason why we're doing direct measurement. It's not measurement for measurement's sake. It's not that we're trying to be accurate just because, of the fun of it. We're saying that once you are able to create that level of accuracy with the direct measures, you're able to even take something like a bag of cement, which is an ultimate commodity, and differentiate it based on its embedded emissions, maybe even charge a premium for it. Ditto, you can do it with a barrel of oil. Ditto, you can do it with a bar of steel. Right, so that's the reason that's driving our interest in direct measurement, and the E-liability. Oh, sorry.
But let me just say, but then anticipating the E-liability, Karthik, for most companies, these direct measurements are only a small fraction of the total emissions over which they have influence and control, and most of the emissions are occurring pretty far upstream. So the contribution of the E-liability method is to be able to take accurate measurements of direct emissions, embed them in the products that are being produced, and then be able to transfer them credibly to downstream companies. And so a downstream company can also get competitive advantage, not from reducing its own emissions, but from how it's managing its supply chain and the emissions occurred in the supply chain. And that's truly the underlying and fundamental contribution of the E-liability method.
That's correct. Another reason why we might be interested in direct measurements is, of course, the tremendous interest we're seeing across borders in something like an emissions-based tariff. And we're seeing in Europe interest in a carbon border adjustment mechanism, in the United States, a foreign pollution fee. And in order to be able to, for companies and countries to be able to capitalize on their emissions efficiency in international trade, you need a system like the E-ledger system that is effectively driven by accurate product level dynamic direct measures of emissions. And that's what this system gets at. So once we have those accurate dynamic product level emissions measures, we're able to basically build a regulatory system around an emissions-based tariff, as both the US and the EU are envisioning. So I want to talk about the three different ways in which companies can go about direct measurement and calculation. But before I do that, Sandy, I thought it might be helpful if our viewers are able to do a little bit of a refresh on the core principles of direct measurement that are in the E-liability Proto-Standard. So over to you, Sandy.
Of course. Yeah, so there's sort of 10 principles in the core Proto-Standard, and two that kind of recur extensively throughout those principles. And the first one is that all entities must record all material direct emissions of their greenhouse gases using direct measurement or calculation, which Karthik will go into sort of how those approaches appear. And the second is that all of these emissions must be verified to a reasonableness standard, which we'll also go into. And these are kind of the two main principles that we see in that Proto-Standard.
That's right. So as Sandy said, what we want is for all material direct emissions to be directly measured or calculated. And there are three broad ways in which you can do this. Quite frankly, when Bob and I first conceived the E-liability approach, I had in the back of my mind that this might end up being some sort of chemical engineering full employment act where there would be lots of chemical engineers out there, helping companies figure out what are the direct emissions associated with their processes. And so the first approach really builds off that vision, which is that we need some sort of direct monitoring devices. We need sampling devices to be able to tell us where the variance in emissions are and what is the basis of emissions from a given production process. We need to have effectively meters on smokestacks or meters on tailpipes in order to be able to count the moles of CO2 and other greenhouse gases as they go into the atmosphere. And to an extent, that's a really accurate way of doing things. And, where it is technologically feasible and where it is economically feasible, certainly companies should engage in that kind of direct measurement because it's very accurate, it's verifiable, and it helps you build confidence and your customers' confidence, your regulators' confidence, your auditors' confidence in the numbers you're providing, and therefore helps you build a competitive advantage. So that's the first approach, using scientifically validated monitoring equipment that builds on the expertise of a vast body of, say, chemical engineers, environmental engineers, and the like. But as we started doing pilots across various different industries in cement, in steel, in oil and gas, in automotive, in tires, in plastics, energy, we realized that actually this is not the only approach to it. This sort of direct measurement using scientifically validated monitoring equipment is not the only way to do it. And in fact, you can do imputed direct measurement using calculations if you know what the underlying chemical reactions in those processes are. So let me give you an example, and then we can extrapolate from there. Let's say you're in the business of making cement. Well, one of the core chemical reactions associated with manufacturing cement that is particularly emissions intensive is the chemical reaction that converts limestone into clinker. The chemical formula for limestone is CaCO3, and the chemical formula for clinker is CaO. The difference is CO2 that goes out into the atmosphere. Now, that chemical formula is known in every high school chemistry textbook. So there's no sort of profound knowledge there beyond what you already have in the public domain. And it turns out that if you're running a large cement factory, you know what the inputs of your limestone and the outputs of your clinker are on a periodic basis. You know what the weekly inputs of limestone are, the weekly outputs of clinker are. And in fact, you have already audited those numbers for your financial inventories, for your financial accounting books. So it's a question of simply putting together two known quantities. So the chemical reaction involved, which is known, and the quantity of inputs for a given period. Like for a particular facility, what is the amount of clinker used? What is the beginning of period value? What's the end of period value? The difference, boom, that's how much clinker was produced in that period. If you know the chemical formula, there's no real uncertainty about what were the emissions that went out into the atmosphere for that facility from that particular reaction for that week. Now, so if you know what are the thermodynamics of the processes involved in your facility, which you really need to map, not very often, once every so often, really only as often as you change the underlying processes, and you have the underlying solid inputs or outputs already being measured for your financial inventory books, then you can impute the direct emissions at the standard of reasonable assurance that Sandy mentioned earlier, fairly easily, actually using existing databases or using a little bit of AI applied to existing databases. So the second approach to direct measurement is what we would call direct calculation. And that direct calculation is an imputation of the emissions from known quantities and known chemical reactions. Now, I gave you the example of the cement factory, but beyond that, for instance, a key source of emissions in the atmosphere comes from internal and external combustion engines, which burn fossil fuels. So if you know what is the carbon content of your fuel type, and you know what is the quantity of fuel you burn, which you should know based on your purchasing invoices, then boom, you know how much CO2 you put out. You don't even need tailpipe monitors or monitors on smokestacks because you know what the beginning and end of period inputs were, and you know what the carbon content of the fuel type is. And by the way, you know what the carbon content of the fuel type is from databases like GREET, which are already put out there by Argonne National Labs. So it turns out that direct measurement, or particularly this subtype of direct measurement, which is really more direct calculation, is not that costly to generate and to be generated at the facility level, which then gets recorded in the ledger, which then, using the allocation processes that we've talked about in an earlier video, will get allocated down to products. So this original fear that I had in the back of my mind that in creating the e-ledger system, we were going to create the Chemical Engineering Full Employment Act, has turned out in practice not to be true because the information is actually so readily available. Now, these two cases that I've talked about, which is the scientifically validated monitoring equipment and the chemical reactions, so the direct measurement using monitoring equipment and the imputed measurement using chemical reactions, these work for certain type of what we would call closed form chemistry. But would they work in the context of open form chemistry with, say, biological reactions, for instance, in cattle farming? That's a question Bob's going to pick up next.
Yeah. So a third major source of emissions does come from hundreds of millions of cattle that are being raised for beef and maybe leather production, and dairy cows that are producing milk products downstream. And there could be hundreds of millions of these all over the world. And they are a major source of emissions, particularly methane, which is a particularly powerful global warming emission. And here the underlying chemical process is occurring inside the animal. And it is not as observable or even as predictable as transforming limestone into clinker. So we have a problem. If this is a major source of emissions, but seems not amenable to the first two types of measurement that Karthik has talked about. And I think here we're going to have to rely on some empirical work, which tries to explain as best we can not just the absolute level, but the variation, what causes variation in the emissions produced by dairy cows and cattle being raised for beef. And fortunately, much of this is known. We know it depends on the breed of the cattle. And that affects their metabolism. It affects what you feed them and the type of feed that goes in. It talks about how long they are being raised until you kill them, because there's a certain amount of emissions per day. And if a cattle is living for 300 days, it's different than a cattle that's living for 3 years. So the duration before being slaughtered or end of life in the case of dairy cows. And the fourth is, what are they grazing on? What's the soil type? Because different soils will have different quantities and mixes of chemicals. And the content of the grass being grown on those soils is another source of variation. And the final one is, to the extent that they are grazing on grass, where did the grass come from? If the fields have existed for several tens of thousands of years, that's fine. If they were just created by burning down a lot of trees and releasing a carbon into the atmosphere that had been stored in those trees, then all of that carbon release has to be allocated to the cows and cattle that are grazing on that now able pasture land. So this is not trivial, but it's not unmanageable. And fortunately, there are scientists working in this field that have created reasonably well-validated models to look at the particular inputs of breed, feed, soil type, length of rearing, and with what is the source of the land, to be able to predict the actual GHG, greenhouse gases, primarily methane, that are being emitted by the cows and the cattle. Now, it's not as accurate as some of the direct measurements or even the formulaic measurements that Karthik talk about, but we believe that can have probably within a 10% error if you actually were to put a muzzle on every cow and cattle in the world, which is infeasible. Well, you could do it sampling, and that's how you verify this, to predict within 10% of the actual number. And that's going to be good enough for our purposes.
That's right. And that last point that Bob made is really important, right? So what we're not trying to do, and what we don't certainly need to do, is to generate a level of accuracy that's needed, I don't know, to publish a paper in Nature or Science or one of those kinds of scientific journals. What we're trying to do is measure the level of accuracy that allows you to commercially manage this so that you can create a competitively differentiable product, right? And that means maybe 95% accuracy is good enough. Maybe even 90% accuracy at first before your competitors catch up may be good enough. And it turns out, as Bob says, that you've got 3 or 4 variables, things like the feed type, the soil type, the cattle breed, and then, of course, the land use change that matter. So if this is a native grassland that is self-regenerating, then actually, grazing cattle on native grassland that's self-regenerating over the course of, an annual cycle, then this is just a perfectly fine use of the product. And you can measure that, and you can have that sort of verified using, the kinds of techniques that we've talked about. Obviously, it's different if you're deforesting sort of, a 1,000-year-old rainforest or a 100,000-year-old rainforest in order to breed cattle. Then that will feature into the E-liability accounting, and your cattle will be prohibitively emissions intensive. So these questions around accuracy bring us to the question of verifiability, because the second principle that Sandy mentioned, beyond the fact that all direct emissions need to be measured, is that they need to be measured to a standard of reasonable assurance. And again, the standard of reasonable assurance can be roughly, as a rule of thumb, be thought of 95% accuracy, rather than perhaps, the 99.99% that you would need for a scientific journal or something like that. And so how would you go about that verification? The key is for the verification itself not to be cost prohibitive, because in the E-liability system, all direct emissions are measured and they are verified at source. And once they're verified at source, effectively that verification tag, along with the underlying unit of emissions, can travel down the supply chain. So one way in which assurance can be done on direct measurement is, as Bob mentioned earlier, through sampling. And in fact, in financial auditing, we use sampling a fair bit. And that kind of sampling allows us to be able to, for instance, look at certain activities or certain units of inventory and say, as long as the sampling was random and the observable units are within the confidence interval of reasonable assurance, we're fine. So, and that's one way in which, for the purposes of financial audits, we are able to keep costs measurable, and there's no reason why we can't use that kind of random sampling for assurance in emissions context as well. But technological tools like AI actually allow you to go well beyond random sampling to something that we call 100% auditing or dynamic real-time auditing. And what that would entail, again, is the use of known chemistry. So if you said, well, we know what is the underlying thermodynamics of the process in this particular sector, in this particular industry, for this particular geography, given, for instance, the energy mixes available in this geography. And then we look at the outputs from your facility, given those known factors. Then if those outputs are within 95% of what we imagine them to be based on that known chemistry, we can give you the reasonable assurance certification. If they're outside of that expectation, that doesn't mean necessarily you've done something wrong. In fact, it might be a good thing that it's outside of that expectation because you've developed an innovative new process that allows you to competitively differentiate and therefore, sell your product at a premium. But that's what then invites the scrutiny from the auditor to make sure that, in fact, you have developed a innovative new process or product that allows you to be outside of what is expected from the norm. So the other way in which the audit could be done beyond random sampling is to use things like AI models to say, okay, what is the generative prediction for emissions for this facility, given the geography, given the process mix, given the known thermodynamics, given the input quantities involved, and are we within a 95% confidence level of that? If so, great. If not, then let's go probe that. And as we probe that, we might be able to validate and verify your winning process. And in that process, through that, you will be actually able to earn more customers. And in fact, we've seen through some of our case studies or pilot studies how companies are co-locating the assurance process with the pilot study itself, in the sense of as companies are doing pilots in the e-liability approach, they're also engaging or looking to engage their auditors in the pilots so that the auditors learn about what's needed in order to be able to cost effectively deliver a reasonable assurance certification for those direct emissions. Because if you can train yourself and you can train your auditors at the same time, and you can establish robust principles to which your auditors can then verify or certify that your emissions are what you purport them to be, then you're in the business of being able to competitively differentiate on emissions. Now, the final thing I want to say before I turn it back to you, Bob, is that everything we've described should be thought of as a phased-in approach, because this is not necessarily something that you'll wave a magic wand and make it all happen at once. We can start with the direct emissions that really matter. So there are a few sort of key sources of emissions in the economy that really matter, like steel, like cement, like internal and external combustion engines, like cows, all the examples we've generally been using through this discussion. So you can start with those, and chances are you'll get to 80-85% of total direct emissions in the atmosphere. Let's get really good at direct measurement of those few items, and let's get really good at direct assurance of that measurement. And we can phase that in over a 3 to 5 year period. And once we've done that, we can think about moving on to other products that might be really emissions intensive as well. We can also think about moving to other greenhouse gases beyond CO2. Methane, of course, is an example that Bob has already used in the context of cattle, but we can start looking at other kinds of greenhouse gases as well. And quite frankly, we can look at other sources of pollutants that might be sort of, important to consider in the context of the holistic management of environmental performance and environmental differentiation of companies. Over to you, Bob, for some closing thoughts on this conversation about direct measurement.
Well, thanks, Karthik, for covering both the direct measurement as well as the verification of the direct measurement. And this is essential. Any system of carbon accounting has to be based on these correctly measuring the direct emissions when and where they occur. And as we've advocated, that's where they should be verified. Now, there's one additional step in the e-liability method, which we've covered in other videos, but there is the allocation of an organization's direct emissions plus the emissions in the products and services it purchases from all its suppliers to its output products. And if a company doesn't do a good job there, then we have destroyed some of the integrity of the measurements that were done upstream of them, which would really be a shame. And so companies have to follow good causal logic in the allocation of their direct emissions and their purchase emissions to its output products. And at the same time that the auditors are verifying the accuracy of the direct emissions, they should be validating the accuracy of the causal logic that each company is using to assign its purchased and produced emissions to its output products, which it will then communicate to its immediate customers anytime it sells one of those products.
Excellent. So thank you again for your interest in these videos, and thank you, Sandy, for your work in bringing these videos into existence.
Thank you guys so much for joining.